So what we've done for today is we haven't prepared any slides or presentations or anything. What we will be doing is talking through just maybe some ideas, and want to really get some feedback from everybody as to what they think the best approaches would be. So that's more the approach for today. So maybe just before we kick off, anybody want to give us a quick view as to what their primary challenge is with recommenders in their world, especially technical challenges?
Yeah, just the relevance of recommender. Have you got the right information? Have you got the right, and is it good enough so that your recommendations are relevant? And how does that all work? It's got to be accurate. And the whole point of your software is that it's accurate, well, more accurate and real time and faster and better than everybody else. That's fine. How relevant is that? And what does it mean? And how accurate can you make it? Can you guarantee results?
Okay, so we can think of relevance as one of the primary things in how would you know that a recommendation is relevant? That's basically what you're worried about.
Now, it should be easy to see the results, because the results should be a significant little green light or uptick in new revenue streams, whatever it might be.
My biggest challenge is that I don't necessarily have the data to build a recommender system. So just the data that I do have, a recommender system is maybe not the best approach to use that data.
So that means that you probably need to worry about a cold start scenario. So beginning from a point where if you have nothing, how can you create data while you engage?
Maybe, yeah. I'm not sold on the idea that even a cold start recommender system, I'm not sold on the idea that recommender systems are going to add value to the data I'm sitting on.
Okay. So what does that mean? That means that if you have no data, and you
no, I have data. I have data, but let me give you a rough idea of what the data is like. So once a year, we have at corporate level, there's several divisions. Each division have their own internal audit questionnaires with thousands of items on. And so each facility will be audited according to those thousands of items. And then once a year, we basically report a percentage score and then try to identify places where problem areas, and then see if we can send resources to help that. So with that sort of internal audit data, I'm not seeing how a recommender system is going to do much that just an interested manager wouldn't be able to do better.
So what do you want to recommend? What is the actual recommender going to recommend for you?
Yeah, that's the thing. Well, what managers tend to decide, and at this point, it's usually down to facility managers. Sometimes it's divisional managers, is they'll look at non-conformances and they have to recommend actions to correct those non-performances. Okay. So maybe if we change the system and we get follow-up data for which actions had better results and worse results, we could then maybe start thinking about recommending actions to follow close-ups. But a lot of the non-conformances have fairly obvious actions. It's implementing them that's difficult. So we get the same problems over and more or less the same actions being recommended every time. And sometimes it's a once-off thing and it's easy to close out, and then there'll be a data point and then nothing again.
Yes. Yeah, so I mean, do you think that's the debate, isn't it? Is it if you had to think of an expert that needs to have a mental or a cognitive interpretation of the situation, and you don't have an ability to deal with random options, wouldn't that recommend to be more like a specialist system or a specialist decision-making kind of rule-based approach rather than something that can make a decision based on data? Because you think about what you need to do because today is about the technology, all right? So philosophically, we discussed before the various options. So if you have an audit approach, because audit normally is highly focused, isn't it? It's economies of scope. So that means you've got a pretty narrow scope, you got limited data that you collect, and a large portion of what you work with has got to do with anomalies. So it's probably more an anomaly detection problem, or is it not?
Yeah, I was thinking if I was going to use AI techniques, and not even sold on those, what would maybe make the most sense is Bayesian network-based expert systems where you can build in a bunch of priors. But then that would be a lot of work, and whether that would add any value to just someone who knows what they're looking at, saying this is the problem, this is what needs to be done, is a little. Yeah, so my technical problem is I don't have the data to build a recommendation system.
Sorry, something that I encountered like with a situation is we basically asked everybody who was involved in a system, like a list of processes or let's say departments, and they have to list recommendations of how to improve it. So whatever their problem is, so they can select things are too slow, or that process is stuck there, or things might go missing or stuff like that. And then you accumulate it, and then you group it by process or department. Basically, you'll see the same themes coming up. Then they'll, for instance, what I've seen is they will mention it, if they can type, they will mention application, the name of the software. This software is crashing a lot or something like that. And you identify like things that you wouldn't normally identify. So that's a way you can gather data that you can like send out like forms and get a reply or something.
Yeah, I think that's what you're saying is that what we trying to do with a cold start is that if you're going to use a reinforcement learning cycle, it basically means that you start from the basis that the system is in learn mode. And that means that whatever input gets provided during a particular phase will be your training data. So that means that if it's in, if you can call it like expert tracking mode, listening to what Jacques was saying, if I say that correctly, you want to focus on collecting those options, and that will then form the basis for whatever the predictor could then predict going forward. But at the starting point, it's entirely being fed by somebody that intervenes. It's a feedback system first.
Yeah, I thought Jacques had a good idea, and I'm also wondering if there's any value in anticipating things aside from just recommending them and trying to look forward into the ability of being able to improve the awareness in advance, if there would be any cost savings for the customer for doing something like that.
Yeah, listen, that's a great one. We love working in that space where what you try to do is using various techniques to trying to figure out what a next best option could be, and then you keep on testing using a number of different approaches. So that means that if you're going to test it with a sampling mechanism, you want to make sure that sample mechanism is correct for the outcome. So the idea is that in this case, let's look at the audit example, say, versus the offer example from Brian, is that if an offer gets presented and it's a sale of a product that is targeted and you understand exactly where it's going to go, your configuration of that recommended technically would mean that you typically will have sales data that historically can be used. You've got an understanding of what products you are offering to the market. You have a price point at which you're going to sell those products. You have a place where the recommender typically will be bolted into, say, a web environment or an outbound or inbound sales environment. And that means that the conditions are fairly controlled. If you have uncontrolled environments, like expert-related environments or specialist environments where the data points are very small, and you have, especially with kind of anomalies within a particular discipline that you will only figure out once you run through one or two processes, that means that the technology recommender needs to learn more than recommend for a period of time. So you need to put it into, let me learn from what's happening in the environment first before I can recommend anything. And that's maybe one way that you solve the data problem. Reed, is that, and are you seeing it as well? So that means that while you're busy learning, you might anticipate and recommend, but because you have no history, it means that you probably need to randomize. So you need to use multi-arm bandits or other mechanisms to try to figure out what is most likely to be taken up by the target.
Yeah, and I think sometimes if you have something just to get started, you could make some Cartesian data products out of some concept to just get the things going so you can continue to refine it afterwards.
Okay, so that means relevant offers, no data to build, anticipating things. Anybody else got some challenges around recommenders or technology implementation challenges?
Vijay, something about the confidence intervals, about the recommendations made, and being able to separate that between I don't know because I don't know versus the stuff that I know is quite noisy. Just having that understanding, that will help a lot.
Yeah, that's a very interesting problem, isn't it? Because you're only really truly going to know what you should have known once you have delivered what you to the unknown and then validate it back.
Yeah, just to make it simpler is to say recommender is making a recommendation in a space where it doesn't actually have a lot of evidence to base this recommendation on. That's the one form of low confidence or uncertainty. And the other one is it has lots of evidence, but it's like super contradictory. Like sometimes this customer likes this and then suddenly likes something else. I've got lots of examples of that, but it's noisy and maybe I don't have the right features. And being able to distinguish between those two would be useful.
Yeah, so the question is, what would the technology look like to solve that? Does that mean that you got a continuous training cycle, or does it mean that you want to interfere with the scoring mechanism? That's probably the options from a tech point of view.
Okay, how do you know that your customers are behaving consistently?
Oh, you don't, do you?
Well, you don't.
Always behaving consistently.
Yeah.
I mean, that's, and how do you factor that in? I'm not talking about schizophrenic behavior, but just inconsistent behavior into a model from the same customer. Does your model allow for that? I don't know. I'm not smart enough, but that would be weird.
No, I think that's a very good point. That means that consistency, if you work with the assumption that the historical views or the historical data that will tell you historical behaviors are representative of how people are going to continue to behave going into the future, and you work with an hypothesis that that's stable, then you probably need to test if that is going to be stable. If you work off the basis that it's not stable and that people are going to be changing, it means that you need to have a technological process that deals with the data, feature store preparation, and all of that will happen. And then maybe looking at a bit like what Schalk was saying is, how do you then understand that you've got confidence in so if you had to look at like entropy or some way to determine how much you really know about a situation, your confidence level could be influenced by how ritualistic the historical cycle has been, and then map that into the future cycle. So that the idea is that if you've got little data about somebody's behavior and you find that their behavior is typically erratic, that means that you probably need to explore more than if you had to do it if you know a lot about somebody and their behavior is very ritualistic. Yeah. So you need to be able to configure that. That's really what your tech should help you to do, isn't it?
Just jumping onto Brian's point there, like so me and my wife use the same e-commerce site account. So you can imagine what happens with my recommendations. It's like all over the show, right?
Yeah, that same connection, same account, and different people acting on that same account. That's going to confuse every model.
I don't know, maybe think about it too much, but the way that I'm looking at it and some of the work that we've been doing is saying that if that personality of that collective behaves in a certain way and gets influenced by recommendations in ways that get them to act basically on the options that you give them from a recommendation point of view, then does it matter if that person is schizophrenic or a unit or a group or anything of the sort, because it eventually, as an organism, gets a personality of its own. So I think that the way we've been reasoning about it is that how much effort would it take to get, Schalk, if you take your example, and trying to really convince somebody to collect data on their own so you can be more accurate for the individual. But you, over time, will probably realize that as a unit, there are rituals of behavior that will give you some consistency in how they would behave, even though it might be very diverse.
Therefore, you're treating each bit of behavior as a behavior, and whether it's collected under one group, it is irrelevant because all the behavior is going into the model.
Just something I wanted to mention. I think in terms of psychology, the first thing to take into account is culture. That can also influence the recommender system and the strategy you want to follow.
So how would you translate culture?
Okay, an example would be, let's say, what would do with news media in America? What would interest an American like in terms of politics versus an Australian? So America is going to have two sides, whereas Australia, when they switch over from the candidate to the other who's in power, they just trash the one and then the other one. And if you want to recycle that news, you have to adjust it a bit to the situation. But what I'm saying is, for instance, news media, what interests one country doesn't necessarily interest another. And those small nuances does make a difference. And I think even within a country, there are some cultural differences. I think like West versus East of a country, and different people have different interests, and you can maybe leverage of that and then get similarities. Then you can make a suggestion that you wouldn't have otherwise picked up.
What would the real model differences be? Because won't the models be the same? It just needs to be trained in a way that it takes into account the preferences, unless you set the context specifically. So that means most recommenders, you need to set your context for your data and for your models. It might be geographical or by language, or so there are a number of ways in which you would set the context.
Okay, I guess the only thing is if you could pick up specifically where the person is located, but I think, as you said, it will probably calculate that within the model.
Yes. Yeah, listen, cultural influences for us is a big discussion. We're trying to find, and if I think about it, the first study in South Africa that we've done 3 years ago, in this region, was to understand the great migrations that happen, and it's very different to the US. So if you have to think of the 4th of July, and you think of Thanksgiving, and you think of just some of the holidays throughout the year and how that influences, and how people's spending behavior across all of especially their service products are influenced, is radically different to the South African or even most parts of the European or Asian regions. So the idea is that you need to take that into account so that your dynamic part of your recommender needs to pick up the fact that there are differences if you're going to have a generic model for recommendation.
Something I'm thinking about now is the recommended system will basically go by a certain, let's say, recommendation. It will recommend, let's say, to this person. But what I'm thinking now is you can recommend, let's say, the same product or service to different people, let's say from 2 different cultures. And if you just, instead of giving the same recommendation, you modify the recommendation so that it has a better chance of selling to that specific person. But that's probably not model related, but that can be maybe an angle to follow.
No, listen, that's the debate, isn't it? So that means that if you're going to drive a global recommender, it really means that if you had to think of, say, the difference between Uber and Spotify. So as soon as there's hyperlocality, and you know that there are very big differences in behavior right down to certain cities, the models are normally highly fragmented. There are no common trained models that will tell you exactly how you're gonna do travel across the world in the same way. So that means that your model pipeline gets fragmented quite a bit, but the scoring engine that's going to produce the recommendation as to what destination you are most likely to go to next, take you into your own behavior into account, because it will be highly personalized. So that means there might even be a model per person. There'll be a model per geography, and maybe even a model per option that you have selected, in this case, the service. So if you select Uber Black or Uber X, whatever it is, there's a combination. And that means the model fragmentation gets loaded dynamically to make sure that you can service an individual's preferences that are quite specific. If you look at the music world, hyperlocality, think of the generic recommender for hyperlocality is really this behavior of events or maybe music that might be liked if you're in a geography or in a culture. But most of your recommendations is around common understanding of the rhythm, the beat, and the lyric, and that means that's universal. So it doesn't matter where you are in the world, the way you consume music in exactly the same way. So your recommender needs to be trained very differently than what you would train it if you had something that's got hyperlocality in it.
Just going back to Skulk's thing, where him and his wife are, well, I think we can assume that they're quite different from what he said. With them, if the model then picks up that there's quite different parameters, would the model not say, okay, hold on, these things are quite different, not separate out the 2 behaviors? And because I know that in any one group, there might be more than one player in a group, and then I can maybe pull it out, and then you actually know that there's 2 people, and then you can track the behaviors independently.
What would that? Yeah, no, exactly. But what would that mean? How would it make the recommender more accurate if it knew that there were 2 people that are very different? And I think that's the question we keep on asking, isn't it? Is that if it knows that if you had to look at it purely without the social science, let's take a bank example. If you're in the banking world and you go to the dentist, and every time you go to the dentist, you put in fuel. And every time your wife goes to the hair salon, she puts in fuel. But you only go to the dentist once a year, and she goes to the hair salon every 6 weeks. The question is, though, can you then separate those actions, or are those actions all just part of the fact that there's fuel that you put in, and that there are other extraneous events that might seem farther apart? But if you get the recommendation to say you want to sell somebody a special hair product, you would still send it to that unit as a whole. You can't. How will you know who the message will be for? You're not going to know, as the data collection part of it is devoid of that clear separation. There will be behavioral differences and so on, but there might be other families that look just like that. There might be other families that behave the same way where their behaviors are quite different. And then you can decide. But that means that the personality of that unit can influence your recommendation style.
If the model managed to see that there are two different people, and that Skulk's got meetings the whole day, he's never ever on this channel between 8 o'clock and 5 o'clock. But for instance, Skulk's whilst on the channel at lunchtime, for instance, then you would know that it's somebody different to Skulk on the channel, because generally Skulk's behavior is after hours.
So, but how would you know?
You'd have to log in. If the person if they came into that recommendation, so say it's Take a Lot, if they came in at Take a Lot and you came in at 12 o'clock at lunchtime, then you know you've got a pretty good idea that it's not Skulk.
But you don't know. That's what I say, Rob. You got no clear mechanism to reliably extract it, and that gets back to the confidence level. You're going to have very little confidence that the behavior are related to 2 or 3 or 10 or 100 people. All you know is that data collection unit behaves in a certain way. It's very difficult, even if you use unsupervised clustering techniques to cluster common times of the day, or so you take time-rated features or other kind of features. It's very difficult to find a way. That means that the recommender just has to know that these things are quite diverse, and it needs to deal with that diversity in that unit. I think that it's the cost of trying to figure out if there are 2 or 3 or 5 people. The story with the target with the baby nappies and the beer scenario. Nobody cared at the time. The focus was highly segmented. So that means they recommended the best nappies to most females after they've had their baby, and not during the pregnancy, because you don't need a nappy during pregnancy, you need it afterwards. And most women will not respond to beer. So what happened is they found out that most nappies had, in the context of a basket analysis, co-occurrence with beer or alcohol-related products. And that means that there was no theory if it was a male or a female, but when somebody went and did a deep dive in social science and did some observation study, realized that it's the husband after work that goes and buys the nappies and gets beer at the same time. So that means that would that recommender then recommend a person that buys beer that this nappy is better than another nappy? That's the debate. The thing is that, or would you still recommend it to the wife or to the person who's got the baby to then influence the person that goes and buys it?
We had a scenario years ago, and it's making me wonder if both Jay and I forgot who else was talking, both have points based on the dimensions available, because we were able to successfully make recommendations on a same account to different people, and we used a parameter of the time of day.
Yes. And
just that seemed to gain some traction in improving the outcomes and identifying the source. And it wasn't, of course, 100%, but that dimension allowed to go deeper into dissecting people across accounts.
Yeah, that's a great point, Reed. I think that we are big fans of time series and time-specific related data, so that in a platform we've got enrichment features where you can take a date and you can configure it in a way that you can set up what time of the day it is. You want to set up when it's travel time, breakfast time, lunchtime. You want to even give those times some kind of categorical definition, and then understanding the time of the month, the week of the month, the week of the year, the month of the year. So that whole spectrum, I think, it's hugely important in understanding human related activity and human rituals. That's a great example.
Yeah, from my side, Joe, no, I think Leach sort of answered, and you answered my question. It was just on Skulk's scenario where we have sort of a wide range and different parameters that can be used to do this. Things like click events, to say that if it's a session, you probably won't have the same recommender in the same session. So I mean, you'll log on, you'll do something, and you'll log off, and so you can use those parameters.
Yeah, because that will probably over time, if you didn't include the time dimension, you will be able to embed the differences in behaviors if one person only ever goes in over, say, a lunchtime period to be able to get whatever it is done that they need to get done. That the time dimension will help you to give a more accurate view of that particular activity, if it's the same person or not, because you're not going to know if it's another person or not. Yeah, that's a great.
So you just use as many different parameters as possible to identify that well, it's not a concern, but if you look at a wide range like that, if you look at my music taste, I listen to almost anything. Okay, and if I log in and I'm in a mood, so different moods. If I'm in a mood to listen to metal, I don't want my recommender to keep on recommending reggae. So I mean, it's exactly the same, guys. It's not a timing thing. It just depends on how I feel at that specific point. Yeah. So shouldn't the recommender be able to pick up as you start what you are doing? If you start listening to metal, it shouldn't think about reggae or anything. It should stick to that genre and recommend more music.
But that's the thing, though. But if you keep on behaving in the same way, recommenders almost always converge. And Eric will talk about it in a moment. I mean, you keep on converging onto the same thing, and that's a problem. Because that means that you keep on recommending things that, I can give you a really silly example. And one day I was working and I was commuting to the States, and I was sitting alone at home, and I realized that we ran out of toilet paper. So what I do is I jump onto Amazon and I bought toilet paper as an emergency item so it can be delivered 30 minutes later. I had some people coming to visit, so I wanted to make sure everything was sorted. I couldn't drive to the store. Delivered it to me, and for the next 2 years, all I got as my number one recommendation were 100 different variations of toilet paper. So what happened is that's the opposite problem. So that means that if you buy it all the time, it only recommends things like that. Or what it does, it says if there's something that's extraneous and it's an emergency item, they might need this all the time. So the idea is you need to find a recommender that can control that intervention, and you can tweak the results continuously. Yeah, so that's why I think the music one is also a good one. You want to be able to converge on the things that people like most of the time, and then you want to be able to test the things that they will be interested in. And you want to know that if you keep on recommending things they're interested in and they ignore it, you need to keep on narrowing it down until the person might only listen to something that they truly want to find very different, say once a year, where other people might want to find different music on a daily basis. So you need to find a combination of that. Yeah, that was a good one. Okay, let's take one more and then we can get into some of the tech. Jacques?
So just one thing that I'm thinking is in terms of, let's say, two people sharing an account or the toilet paper example, is there like, if you could split it between, let's say, using short-term data and long-term data. So yeah. For instance, if you're checking out beers, then you don't, and they know for some reason it's a shared account, and then you just get items related to beer, and you don't go, like for instance, if it's like a year later, you're not going to keep on recommending nappies. Like for each product, you've got a different. So for instance, I don't know exactly, but I think you get what I'm saying. I get it. In some situations, you only use the recent data, and in other situations, you can go far back and collect long-term data.
Yeah, no, definitely. And I think that comes back to some of the things earlier, like confidence levels and so on. So if you have a huge amount of confidence in a generic feature, like something that you sell that is highly ritualistic, or something that you provide to your client base that you find is taken up all the time, you can make that basically a long-term cycle of training where your time periods can be longer and your model training could be slower. But then you get all the way down to models that you might train on a weekly basis or maybe on a daily basis. And in the ultimate situation, you want to train all of the variations of the individual itself in real time. So that means that you want to have that stack score in an ensemble, so that you can have the less about the person's immediate actions, the more you drop into the models that give you the long-term view. So I think that's how we've been using data that has got long-term versus short-term impact, so that you can really take care of, even if you just had to take the existing long-term rituals, you'll be able to serve somebody better than trying to do it manually or trying to not have any understanding of those interactions. Is that Jacques? Is that?
Yes, it's just a quick example. What I'm thinking is if someone, what do I want to say? Some accounts you use more short-term data, for example, and other accounts you use the long-term data. I don't know if the model can figure something like that out.
Yeah, definitely. So model selection, yeah, for sure. We wanted to, Eric and I was trying to set up one today. We didn't have enough time to get it done, but the idea was to show how you can have like 10, 20, 30 models, and each model will do something different. You stack them all together, and we've got other stacked models that we can also show you. But they are definitely, we love that approach, because I think that sometimes what happens is that we get excited, or we spend so much time trying to get one model to fit all of our problems that we really get stuck. And what you want to do is you want to find ways to fragment it so that your time horizon is something that is really a core dimension. And especially if you have somebody that that behave very differently on a day-by-day basis. You want to be able to get models that are quite specialized just to the individual. Eric, do you want to, maybe we can just tackle some of this together. Just talk through maybe some of the tech problems, and then we can maybe show some examples.
So I think there's lots of different philosophies to, well, no, maybe philosophies is too broad a word actually, but like technical approaches to building these recommenders. We were just going to show a few today on how tech can enable them. The sort of broad problem that we're looking at is recommending from a relatively small number of options when you have a fair number of data about the people you're recommending to. I guess most commonly studied, or like most commonly case studied recommender systems of, say, Amazon and Netflix are more of a situation where you have huge numbers of things that you could potentially offer and very sparse data, which is quite a different scenario. And we found in the like insurance, banking, telco sectors, it's actually more relevant to the case that I was talking about, where you actually don't have a million things that you could potentially show the client. You have 50, and you actually know quite a lot about the client, and you know about how people have reacted to those offers in the past. So it's a slightly different, you follow fairly different sort of modeling approaches for those two problems. So we're going to look at the one where there's not as many things being recommended. If you guys are interested in the other approach, like I said, that's probably the most case studied thing. So you just Google how some of the Amazon or Netflix problems, I'm sure you can find a lot of information on it. So we just thought we'd step through how the process would work. The first thing would be you need to actually get so there's the model training piece, and then there's the model deployment piece, right? So the first thing is getting some data. You can ingest some data that we have from a CSV file, and you can ingest that data. We've already done so, but that's how you could do it, and take a look at that data. And obviously there's you can see it has things like education, language, the client's balance, their personality. So we've added some behavioral features, the segment that they're in, their marital status, their gender. So those sort of factors. So some like balance being more real time, others being more sort of fixed demographics. So we're not going to go through the exploratory data analysis piece today. Assume that has already happened. Obviously, it's very important and you need to do it, but let's take this as a sort of prepared data set. So what we then want to do is build our models, and there's 3 different sort of approaches that we want to talk about today. For the first 2, so the first thing you need to do is create your feature store from that data you've ingested. And we can store the way that we do that so that it's easy to repeat. And once you need to say what sort of types your data has and all that sort of stuff once you're putting it into a more structured form for the prediction. And then there's, like I said, 3 different philosophies that I'm going to look at. The first is you just train you have your data set. If you've say got 10 offers like we have in our data set, you have a row for each client and the most recent offer, and like whether and the offers that they've taken up. So like the most recent, either the most recent or just the offers that they have taken up. I think this one is just the offers that they've taken up. So you have one column as your response column, and you train a model to a multinomial predictor to say which offers are clients like this most likely to engage with. The second approach is to train 10 different models. So instead of just training that one multinomial, you instead train 10 different models on 10 binary response columns, and rank the offers using the results of those 10 models. Then with both of those, you need to decide if and how you want to put them into sort of a testing framework. How do you just want to always use the model results, or do you want to have some degree of randomization, and how do you want to do that? And then the last thing that we're going to look at is doing a multi-arm bandit Thompson sampling to as a sort of different philosophy. So you sort of store a distribution associated with each offer with a bit of segmentation and make people offers based on that. And then, I mean, depending on how things go, and if you're interested, we can talk about some approaches that combine the two, so Bayesian Thompson sampling approach using linear regression so that you can include the details of the features, which is something we're working on at the moment. So for our first two, let's first start with our multinomial one. So we have our multinomial training data. We want to pass that into our feature store. So we have our multinomial feature store, and we can then split the testing and training set. So we can say we want to split it into an 80-20 ratio. And you can see those two splits there. So then we have our data that we can actually put into our machine learning framework. So we're going to use an AutoML approach for this. So we'll set up our predictor. So we give it some descriptions. So the name and description, what are we trying to do? What is the model ID? Which data set do we want to use? So that's the frame that we just set up. What approach do we want to follow? So you can choose a whole bunch of individual algorithms, but just for the sake of this, we're going to do the AutoML. You then say what category it is, and then you can store versioning information. Let's maybe do this as a new version, so we can store that. So we're going to say 005 is train, can save that, and then all that you do is generate your model, and that will run for a while, and you can see what the results are as things go along. Obviously that can take a little while, so I'll just show you one that we ran previously. So yeah, you can see all the models get created, the accuracy levels, and you can choose. So say, and you can, if you want to dig into these models in more detail, and you should see the confusion matrices and variable importances and all of that sort of stuff. And then you decide which of these models you're actually going to want to use to make your multinomial prediction. And you'll go ahead and save that model. So we then have our multinomial recommender model working. And then Jay, I don't know if you want to talk about, so that's the training piece. I don't know if you want to just talk about the deployment piece for this model.
Yeah, so what will happen from a deployment piece, and we can in a follow-up session maybe set up one that goes all the way into production. When you say deploy there, the model gets pushed into the runtime environment. That's our client pulse responder scoring environment. And the other thing you could do is if you click test model there, maybe to show them what it looks like, you click test model and you click default. What it does, it generates you a default, just kind of like an entry view that you can just try out to see what the scores look like when you want to see what's happening with your predictor just by eyeballing it. But then once you're done with this, you then go to your projects and you define a project that will then do, the rest of the work for you. So in this case, yeah, you can just see there, it just returns all the, in this case, a label and the scores and the probabilities of this particular model. So that means that up until this point, the issue around the no data and many of the questions we had discussed earlier, these things that we've showed you so far almost need to be out of the box. You want to do these things pretty quickly so you can solve some of the more complex problems. And that means that when you go to projects and we want to configure a new recommender, let's go to deployment, I think, first. I might have, let me see if I've got one there. And you just go to recommender. There is a generic one there. You can maybe just show everybody. Yeah, I just use recommend. That's a very generic one, yes. But I think it's a good one to look at. So what you can do, you'll then define what kind of criteria you want to have in place when you productionize your model. So what will happen is that there where you've got prediction model is you will tell it which model or models to load. And at the moment, we've got a limitation of 64 models per scoring engine. We're busy testing at the moment a framework that will get you thousands of models at a time. So the idea is that especially if you've got smaller models, you'll be able to load 2-3 million models, and you can then have a pipeline that automatically generates them throughout the day in real time, and your models get reproduced. And if any one of them fail, you then go to your base model. That is the one that is trained on longer periods of time if you don't have a model, say, for a customer or for a particular situation. So that is one of the ways in which we see that the no data to build, and then how do you anticipate things. And I think also what we would do with the concept of confidence levels and the consistency issues is that we want to make sure that when those models get trained, that you can do that continuously. So that means model drift and data drift and a lot of those kind of issues. The idea is to get those to really get away from that kind of problem. Then the model selector is if you wanted to use some data point to decide what to do. At the moment, the selector is mostly for kind of discrete values. We're working on a continuous view as well. So you could say anything over this value or over this category or in this category, use model A versus B versus C. And that means that you can at some point get to a point where that model selector is a customer number. So that means it's actually designed specifically and built just for one customer at a time. Then the parameters from the data source means that you want to take your feature store as an input view. And the offer matrix, we used to use the language called product matrix, and we've been working closely with a client who used the word offer, and I think offer is far more relevant in this context, where you've got a lookup that is done based on a product name or whatever it is, and you get a price and other properties that is nothing really to do with your scoring engine, unless you want to take the price from your offer, recalculate it, and then provide it, to whoever's going to be using it. And then the plugins means that you can go and pick up the out-of-the-box scoring engines plugin is literally just a handful lines of code where it gets a score, it prioritizes it, and it pushes it out to wherever the score is going to be received. But we find that most enterprise and more complex projects require a lot of work to happen around that. So you might end up having, say, 3 or 4 or 5 models that you want to stack together. You might want to use a binomial to decide if you're going to make a decision about providing somebody with a certain set of offers or not, and then you can use a multinomial to decide what the offers are. You can use an autoencoder to rank and sequence it for you. So the idea is that you can use a multitude of different models that are stacked together, and you do that inside your plugins environment. And I'll add an example plugin code in a moment if anybody wanted to see that. We can maybe just show that. But then we've got budget tracking and those kind of tracking. We just used to call it matrix tracking, and that works exactly the same way as you do it with Google AdWords and AdSense. It does exactly the same thing. So that means it's got a multitude of two-dimensional matrices that are high speed, can be accessible at high speed, that you can control whatever numbers are in those budgets. So the budget could be based on a number, a score, a value, or something that comes from either your feature store or any of your other corpora that gets loaded dynamically. You can configure that in any way you like. And then you got like your whitelisting if you want to do testing. And then your multi-arm band, and Eric will talk about it in a moment, is there are a number of options that you can use to configure whatever kind of multi-arm band that you want to use. So out of the box, you got like an epsilon greedy or any of the basics, but then there are a number of other ways in which you can configure complex interventions using different ways in which you can do sampling and test options. Like a lot of the conversations we had earlier, the issue around the short-term data or the dimensions that are available or cultural influences, a lot of that gets tested through this configuration. Eric will show you in a moment what that looks like. So that means you can set up an environment where you can decide what your contextual variables are, what your values are that you want to present, because it could be an offer or a message or a product, whatever that might be. And even if that recommender that recommends something, the output could just be a key to a lookup from your offer matrix to present an offer or whatever it is. So you can make it's configurable in any way you like to deal with the nuance of how you. And anyway, so there are other features that are currently not on this list that we will include over the next few releases. So it's in motion. We're working on it. So what I can just quickly do, just for anybody who wanted to see that, Eric, if you just want to go out of that project, let me just quickly add what a scoring environment would look like, and I'll just go add it to the plugin. Somebody can just see what it looks like. So we just used to use a language like plugin, but again, we've had some great influence from clients that call it post score. So it just means that it's after you've done the scoring in the models, you can then go and influence that value of whatever the scoring result is. If you go back, if you just refresh it and you go back into it, and maybe just then go to the plugin, that'll be great. So I can just show people how much control they'll have. So that means that the API to the recommender can be altered. You can define whatever you want the API to be. The API will perform a whole bunch of work for you. And in this case, if you go to the post score and you go into it and you just scroll down a bit, what you'll see, just up there, just at the top of the class, sorry, Eric, just at the top, I just want to show the name. So you'll see there's a thing called get post predict. That get post predict essentially gets loaded dynamically as a plugin. So you can create multiple cases, and you can even load other cases as scoring, their post predict scoring into your case. And you then have full control over whatever scoring was done by the engine, including what the multi-arm bandit is doing. And there's literally, this is like the template that comes out of the box that helps you to go and pick up the domain probabilities and the domain names and basically the whole scoring environment that you then have access to. And you can decide what you do with the offers that got returned by the predictor. Because what we often find is that you might have a model that in real time you want to influence it. So there's a thing called in-params, and that is when you pass through the API additional parameters to help to selecting which option is going to be the best. So that means that if you have a recommender that is bolted into an app, or a recommender that's bolted into an inbound, call center, or bolted into some other implementation, you can pass parameters other than what you have as part of your channel input when your model was trained to decide what the output is going to be of that particular recommendation. And then once this is done, then at the top, let me just show them, there are two buttons there. We don't have to do it now, but just to show everybody. There's a button called Generate and a button called Build. Just further up, I think it's at the top of there you see there's Generate and there's Build. What we do is we set up a deployment pipeline, and Generate will essentially create the entire code structure and environment that will take the code from the plugin and morph it into basically a deployable environment. And the Build will push it off to a build server. So the thing is that we don't build servers. So that's normally something that's quite standard. So you might have an AWS pipeline, or you might have a Jenkins or some other server environment that will do the builds for you, and we'll push it from there into your execution pipeline. But the Generate can be done also in a number of ways. The one that we haven't got included here is you can also generate, say, containers, Docker containers, if you wanted to deploy it into Docker. And the idea is it's fully configurable when you get into a way that you want to deploy it in your environment. So that means you can keep on experimenting with new ideas and cases continuously. You don't have to worry about the long execution cycles that are normally needed for productionization. And especially if you look at some of the issues that we had today, if you wanted to test different ways of anticipating things, you want to keep the API of the recommender the same, so it keeps on recommending something. You want to tweak the approaches that can be dynamically tweaked, and we'll show you now. Or you can even tweak the way in which you want to influence the scores based on other services. So you might call external APIs, so you might get some more data from somebody's social media feed or some other mechanism that will help you to sequence what you're going to provide them with. All of that is dynamically determined. And then the part that is not dynamic, when you change your scoring, you generate and you build, and it's normally it takes a few minutes, and you basically in production. Yeah. Okay, Eric, so maybe just show them, because I know we're out of time, so maybe just show the dynamic setups.
Like the other approach that I mentioned was building one model for each offer or campaign, whatever it is that you want to recommend. But that, in terms of technology, is similar to what we did for the multinomial ones. I think given the time, I'll leave that as an exercise for the listener. The third approach of doing a more sort of multi-arm bandit Bayesian approach is using sort of Thompson sampling with a bit of segmentation to rank your offers. So this is one that we set up before. We want to have this something to rank offers, meetup offers. We first do a bit of setup for it. That's our meetup recommender. It's going to recommend our offers. And then you say which production environment do you want it to be sent to. So this is our demo client pulse responder. So you'll have something running and you can change the configuration in that. And where is your training data coming from? So this is our same data set that we had before. What you do then is, to add a bit of context, you can basically segment your multi-arm bandit by a couple of variables. So in this case, we're going to split it by property ownership. You can use this to retrieve all of the potential variables from your feature store that you've linked, just so that you make sure that the variable you want is actually there, and retrieve the values for that specific variable. You then choose the approach for your multi-arm bandit. So the epsilon greedy, binary Thompson sampling, epsilon greedy with Thompson sampling. You can choose to test options across segments and add a cache if you want people to have some sort of stability in their office. So once you show them something, if for whatever reason you don't want to show them something else for a day or a week or an hour, you can set that cache. Then you set the parameters for that multi-arm bandit configuration you've chosen. How highly do you want to weight success versus failure? How often do you want to test across different segments? Whatever you want to to be. If you have an epsilon, what do you want that to be? And then you specify the options that you want to test, as well as your sort of prior information that you want to put in. So, I mean, this table is obviously we haven't populated it with all 10 offers for both options of this variable, but to give you an idea, you would say for the values of our segmentation variables, variable 1 and 2, we have the set of things that we want to recommend. It doesn't need to be the same for both. And then if you've chosen the Thompson sampling approach, you set your initial alpha and beta. So alpha and beta being 1 and 1 is a uniform distribution, but if you have prior information, you can include that by tuning these parameters. And then you can also put in sort of a business weighting if you want just to force something to be recommended a lot, you can set that. That's all stored in a JSON config file, which gets saved and pushed to the runtime. So once you've set that all up, you go to here and push the updates to your client pulse responder, and you'll then be able to have a API interface where you can get ranked offers using that Thompson sampling approach. So that works quite well. I mean, the one sort of obvious thing that's missing is that if you have a lot of context that matters, a lot of variables that are important, then this can't capture them, which is why we're working on what I mentioned before, of combining this with a regression approach to allow you to use the context. So, I mean, it's called contextual bandits. There's a few different approaches out there, but that's the next enhancement that we'll add to this, to combine the first and second approaches that we start with the models with this approach of the sort of multi-arm bandits distribution.
I think that, Eric, maybe just worth mentioning that at the moment, if you wanted to add a lot of context, you can just make sure that it's embedded in your feature store or in your corpora that gets used when you do the scoring. So it's just for if you wanted to do complex multi-arm bandit context, then be busy working on a version that's going to allow it to complex.
Yeah, it's only for this multi-arm bandit piece that I mean, obviously you can have context for every other algorithm. It's easy to incorporate. Yeah.
So Eric, I know that, listen, we're out of time. So I was just thinking, should I quickly show what that scoring looks like on maybe just a real environment for everybody wanted to see that? So when you deploy all of this, the way that you would do it is there's a API that we publish through the scoring engine. It's got quite a rich set of APIs that are basically available out of the box that you can use to test any of your scoring environments. The thing that we haven't spoken about today at all that we'll do at some point in the future is we also show how you can use like Jupyter notebooks and so on to go into the detail. But in this example, if you look at the payload at the bottom here, and let's say you execute, in this case, customer 984, what you get is this kind of result. Let me just quickly show you what it looks like if you had to go look at the raw payload that comes back. What you have is this kind of effect. It shows you if we were caching, it shows you if there were an explore exploit, if you had your epsilon greedy turned on. You then have your final result that pushes your final result, whatever this was configured as part of your predefinition. And if there were in parameters, in this case, there weren't any. But in this case, it shows the offer and the score that was used. And you'll see that there's an internal mechanism that deals with scores, final score, and modified score. So it gets used for different kinds of applications depending on how people want to implement it. But the idea is that every time that you call the API, the payload is standardized so that you know what to do with it. You'll see that in this case, the offer name is just a number, like a 0, 1, 2. But in most cases, that could be a message, or it could be a product, or it could be a reference point, or it could be an action, or whatever that you might go and look up, or we will do the lookup inside the scoring engine. It gets configured entirely based on the implementation where it's used. And what we're normally trying to get clients to do is to standardize the API calls. So when you do the call to the API endpoint, if this is standardized, it basically means that you can evolve your models, keep on retraining your models, change things all the time without ever affecting where it's bolted into the operational environment, because you basically keep everything in production 24/7. It never goes down. So what some clients have done is they run two separate infrastructure for their scoring engine. One is run basically when you've maybe on the one day and you're busy updating the next one with new data, new models, and you switch across to the new scoring environment while you're busy training the other one. So you rotate. So there are a number of different mechanisms that are being used so that you just can stay in production basically 24/7. But yeah, that was just an example. So that means that if you pick any other kind of what you can do is you could go and just test some of your results with your different offers and your scores through the Swagger, and then we bolt it normally into load tests environments and so on as well, because you normally have a response time of about 5 to 10 milliseconds, depending on what the total score environment looks like.
Fantastic, Jay. There is so much information and so much you can do with the platform, with the Workbench. And just a brief teaser for those people that would find that useful. We will obviously be going down this path of providing more and more workshops on how to use the product. Thank you to Jay and Eric, and also to the people that posed some interesting questions at the beginning to get the conversation rolling. I'm going to call an end to the formal part of the afternoon's events at the moment in about 4 seconds, but we will stay on to answer any questions and just have a general chat for a few minutes. Thanks, everyone. Cheers. Bye.